Welcome to the stage, Chairman of Ivanhoe Mines, Robert Friedland.
Oh, we got such a small group. Come on up to the front here. So we'll just talk about Mother Earth for a moment. So we're traveling, we're rotating on our axis at about 1,000 miles an hour. And we're going around our sun at about 66,000 miles an hour. But a lot of people don't realize our entire solar system is rotating around the galaxy like this at about 540,000 miles an hour. So that means that one galactic year to go around our galaxy is about 230 million years. 230 million years for us to go around the Milky Way galaxy. So when the dinosaurs had a very bad day 68 million years ago, that was only a third of an orbit around our galaxy. That was like yesterday. And it took several billion years to get to this moment. So thank you for being interested in what I'm going to tell you. So if we spent an hour together, we'd go 450,000 miles. That's the speed at which we're moving around our solar system. So if you look at this dot we're all living on, that's our home. I'm quoting Carl Sagan, everybody you love, everybody you know, everybody you ever heard of, everybody who ever lived out their lives on this little dot. Now, these two guys are the most powerful people in the world, and their discussion in the last few days is about the supply chain, because Mr. Xi Jinping threatened to cut off a series of critical raw materials without which we could do absolutely nothing, because everything you've ever touched, we either mined it or we grew it agriculturally, including the chair you're sitting on. And so the supply chain is primarily controlled now by China, and we want to explain our existential position and what we're doing about it. And then these two guys have a strange relationship, and mostly they're united in war. And the way war is going, it's using the same critical raw materials. We want to green the world economy. And so we're in a very dangerous position as the demand for these critical raw materials is intensifying. So currently the Defense Administration all over the world wants to build up military expenditure. Japan is building an army. Taiwan is turning into a giant porcupine. China is arming to the nth degree. Europe is going to spend 5% of GDP on rearmament, and the United States. And the critical raw materials going into this enterprise are the same as the ones we use to green the world. These modern armaments that America uses, they're called ATACMS. The shells are called copperheads. They're made out of copper. And when that copper explodes in Ukraine, it's not recycled. So we want to explain to everybody in this audience how critical these raw materials are becoming. And we always start with this image, which was only 3 years ago when these children saw Ukraine and Russia descend into war. The volume of armaments that have exploded in the Ukrainian conflict is greater than the volume of armaments that exploded in all of World War II, absent the nuclear bombs, 2 of them that we dropped on Japan. So there's an astronomical amount of metal has gone into this useless conflict. Just an unbelievable volume of metal has gone into this conflict. Now, all things military are going to be wireless. You're all aware of artificial intelligence, and you're all aware of drone warfare, but drone warfare is all controlled by 6G wireless. Your Apple phone, if you have one now, is 5.5G. And there's a metal in your phone called scandium, without which we will have no 6G wireless. And so just to give you an idea of what's happened as cellular telephones have evolved, we've gone from 1G, 2G, 3G, 4G, 5G. 5G plus is what Apple has right now. You have an Apple 14 or 15. And we're heading to 6G. You can see how the spectrum is being divided more and more. But this is the spectrum that will be used for all drone warfare and all military requirements. And none of this can happen without scandium metal. So I'm giving you an example of a metal without which nothing can move forward. When you see in the newspapers or discussion about critical raw materials, there's a lot of metals you've never heard of, and without them, we just won't have a modern world. Now, China has been spending 30 or 40 years putting an incredible amount of effort into dominating the supply chain for these critical raw materials. And they've placed, as of today, export restrictions on gallium, germanium, antimony, tungsten, tellurium, bismuth, indium, and molybdenum, which may mean absolutely nothing to people in this audience, but I'm going to give you an idea of how freaky things are really becoming. So China could have stopped all automobile production in the United States in the next 2 to 4 weeks if they just cut off these critical raw materials. We don't know what Donald Trump did or said, but he said they're going to allow GM to keep making cars in exchange for something. We don't know what the deal is. But you need to understand that almost everything you touch today is dependent on a supply chain that goes back to China. Now, in the meantime, there isn't enough electricity in the United States for our high-tech ambitions. You've all heard about AI, and I want to teach you a little bit about it. That's a picture of Apple's headquarters. So,
well, you touched on a great point with energy. I think it's hard to overstate how important energy is to the future here. Eventually, chips, network gear, that will be made by robots, and we'll make that very efficient, and we'll make that cheaper and cheaper. But an electron is an electron. Eventually, the cost of intelligence, the cost of AI will converge to the cost of energy, and if it'll be how much you can have, the abundance of it will be limited by the abundance of energy. So in terms of long-term strategic investments for the US to make, I can't think of anything more important than energy. Chips and all the other infrastructure also, but energy is where I think this ends up.
So, what is energy? What are we doing here on this planet? What are we doing to each other? Because we're racing towards AI. He talked about robots. The AI, the servers, everything is made out of something. The robots are made out of something. You're going to have 10 billion robots running around like the Terminator, all wirelessly controlled. So let's just take a look at a data center here. Data centers by 2026, which is basically tomorrow morning, are going to demand 1,000 terawatt hours of power, roughly equal to the electricity of Japan. And Japan's the third largest economy in the world. This is just in the next 2 years. I mean, it took 5 billion years for us to evolve to the point where we could have this talk. 2027 in geologic time is just a second from now when we need 1,000 terawatt hours for data centers. Now, when you take a data center apart, here's one. This is a Tesla server rack. I'd like you to know what's inside that data center. So every one of those servers needs gold, iron, gallium, antimony, tungsten, silver, rare earth elements, indium, tantalum, palladium, barium, niobium, and titanium. Every time you do a Google search, every time you use your phone, every time you do a WhatsApp, every time you're guilty of turning on any form of computer, PC, iPad, you need those metals. And everything you touch, we mined it or we grew it agriculturally. So that's why they're called critical raw materials. So Microsoft just put in a baby data center in Chicago. That's not far from here. And if you look at the metals that went into that data center, there was 2 million kilograms of copper, 61,000 kilograms of barium, 10,000 kilograms of antimony. You can see all the metals. Now, the ones that we mine are in green. We happen to be miners. We discover and develop those mines. And we have to mine those metals in a greener and more conscious way, because if we mine the way we used to mine, there's no point in trying to electrify the world economy, because we'll create so much global warming gas to mine the metals to replace crude oil or coal that we'll just never get there from here. So we face a very profound dilemma. Now, everybody in this room has done a Google search. I'm sure everybody has done a Google search. There are billions and billions of them being performed every day. If you do a Google search, bip, you're using the amount of electrical energy it takes to run a 100-watt light bulb for around 12, 15 seconds. That's about 1,000 joules of energy every time you do a Google search. And it's not free. Electricity is not free. It's paid for by advertising. If you're going to go to Grok and you're going to do an AI search, you're using between 10 times or 30 times more every time you push a button. So it'd be like burning a 100-watt light bulb for 2 to 3 minutes on every AI search. And your kids are going to grow up on AI. Everything's going to run on AI. So the demand for energy as we build these servers and go to AI just goes to infinity. By the time we have 10 billion robots running around, running on AI. The electrical demand on the supply chain to provide these metals is anything beyond your wildest imagination. This is what Shenzhen, China looked like in 1982 when I was 32 years of age. I was there. And I've been in China since 1981, and this is what it looks like today. So the explosion of metal demand has 8 billion people on the planet. Everybody sees everything on the internet. Everybody wants everything. The demand is completely psychedelic for these raw materials. Now, the problem is that when you go to alternative or renewable technology, the technologies are absurdly metals intensive. A typical electric car uses 6 times more minerals than a car that runs on gasoline. 6 times more copper to build an electric car than to have a Ford Mustang with a V8. So an onshore wind farm uses 9 times more minerals than a gas-powered power plant with similar output. So when you want to go green, you need our metals. Without our metals, nothing happens. And it's just astonishing how many people don't understand anything about the supply chain. I think people think a ham sandwich comes out of a refrigerator. They never think about 30 million pigs a month being slaughtered in a river of blood outside Chicago. 30 million pigs a month. So we're accelerating the green transition in China. China is talking about 1,200 gigawatts of installed solar and wind. Now, a nuclear power plant is 1 gigawatt. Let's repeat, a nuclear power plant unit is 1 gigawatt. China's planning to have 1,200 gigawatts of solar and wind. 6 years earlier, they're going to spend $800 billion by tomorrow morning to modernize the transmission grid and its underlying software. Our grid is just a piece of junk in the United States by comparison. If all you buy a Tesla and plug it in at 4 p.m. when you come home, our grid will just roll over and die. It isn't even close to be ready to have everybody having an electric car. So it's easy to build the car relatively, but to replace the entire grid, we need an astronomical amount of green metal. This is energy as it's being added in China, and you can see that we've added no energy in the United States at all. Our grid is over 100 years old. When we had a fire in Paradise, California, I don't know if you remember that fire in California a few years ago, almost 300 people died. The power line that went to Paradise, California was 106 years old. Did you know that we have power lines in the United States that are 106 years old? It's just incredible how much effort and money went into broadband, internet, Netflix, all the sexy technologies, and how that sucked up and prevented money from going into basic infrastructure. So that's Shenzhen. There was nothing there when I went to Shenzhen in the 1990s, and now it's a city that looks like New York. That's where Tencent is headquartered. Now, how big is the oil market? You want to get rid of crude oil? So in size, crude oil is a 2.1 trillion bubble, and those metals are what have to replace that oil. You need nickel, aluminum, copper. You don't really need gold. We used to put gold in our teeth, but now we use nice white enamel. We don't need gold for that purpose. You need a lot of iron ore, though, for the infrastructure. So as you phase out crude oil or coal, the demand on metals is just crazy. Now, we're thinking about $2.7 trillion a year if we're going to get to net zero by 2050. And it's getting hotter and hotter out there. So when you go to an offshore wind farm and you take the power cables, there's a reason why power cables are so expensive. Look at all the copper. Copper conducts electrical energy better than anything in the periodic table, except for gold and silver, which are just too expensive for the purpose. And so we have a real pressure on copper. I'm in the copper business, and I just got to give you an idea of what we're talking about here. So currently, just copper wires is a $267 billion a year business by 2030. And the demand for these copper cables looks like that chart in electrical generation in China. It's just straight up. So this is how much copper we have mined since we were monkeys. We've mined 700 million metric tons of copper metal in the history of our species. You can see if we put that in a big cube in relation to the Eiffel Tower is 323 meters tall, so it's a pretty good chunk of copper. Now, that's the copper that is the modern world. 700 million metric tons. Now, if you want to get it back, if we tear down everything in the United States of America and restore it to how it was before the Eskimos crossed from Russia and there were no people here in the Western Empire, if we just go back to primordial nothing, just nature, there's about 300 million metric tons of copper in the American grid. We can go back to the Stone Ages right here in the United States, and we can recycle 300 million metric tons. But if you stayed in a home or drove in a car or flew in a plane or in this room, that's where it is. And there's another 100 million tons in Great Britain, and there's 200 million tons in, say, Asia and India. And basically, you'd have to rip down everything that human beings have ever built to get that 700 million metric tons back. So that took us 10,000 years to mine that copper. Let's have a look. So if we start, let's go back to 4000 BC. We've mined 700 million tons. So to maintain 3% GDP growth with no electrification, no electric cars, no data centers, just the way we did things in the past, we have to mine that same amount of copper in the next 18 years. To maintain 3% GDP growth, we need 700 million more metric tons of copper in the next 18 years. Did you hear what I just said? This is why, Donald Trump said, I'm not going to help Ukraine unless you give me access to critical raw materials. You've never heard a president of the United States talk like that before, because we're actually facing a crisis. We cannot simultaneously green the world economy and kill each other in wars, because the two enterprises demand the same critical raw materials. And it's tough enough for us to find the critical raw materials. We need to leave a better world to our kids and our grandkids. And those of us that are in the mining industry, and this is no bullshit, we have no idea where we're going to get that copper in the next 18 years. We really don't have a clue, which is why the copper price is so high and will keep going higher. You can literally build your house out of concrete, buy copper bricks, make bricks made out of copper, and just cover it with gypsum wallboard and leave them in your walls. And in 10 or 15 years, you'll be able to tear your house down, and they'll be like gold bricks. And all these metals are going up in dollar terms. So we really face a crisis, how to get this metal in a green way, how to get this in an efficient way that doesn't destroy the earth. Otherwise, we're addicted to hydrocarbon and coal. And we're making more and more babies. So this is just for 3% GDP growth with no artificial intelligence. Tell all these guys to stop talking about AI. It's bullshit. Where's this metal going to come from to make these servers? And where's the energy going to come from? Because China will burn coal to run their AI if they have to. Because if my drone is coming to kill you, and your drone is coming to kill me, drones are driven by this wireless technology. If I'm a millionth of a second faster, you die, I don't. And so the AI driving those drones can recognize every one of you in this audience. And it's just incredible ability to kill each other. We really need to think about where this metal is going to come from and how we're going to get there. Now, since 1900, the energy needed to produce copper is increased 16 times per pound of copper, and the amount of water we need per pound of copper has doubled since 1900. So we're mining lower and lower grade ores in order to get the same amount of metal. And this is really a crisis. We mine the easy stuff first. That's in Bisbee, Arizona, circa 1900. So that was 125 years ago, when Thomas Alva Edison and Nikola Tesla and George Westinghouse we needed copper for electricity. But, grades are falling in copper around the world. So we need 6 giant Tier 1 copper mines to come online every year by 2050. And 40% of that production is currently thought about going into electrification, data centers, and grid upgrades. Heaven forbid it goes to war. And in our copper mining industry, the amount of money we need, and we need a better way to mine, we need a greener way to mine, we need a more sustainable way to mine, and it takes a huge amount of energy to mine that copper. So, according to a recent study at Cornell University, the copper price has to immediately double for us to be able to even go out there and try to do this. And so copper has always been a proxy for money. You know, our American penny has about 4 cents worth of copper in it. And so we're getting away with a penny, but our current new pennies are made out of zinc. They look like they're made out of copper, but they couldn't make them out of copper because copper is too valuable. And now the United States government is getting rid of the penny. So copper has been money in China for 5,000 years. Copper used to be money in the United States along with silver and gold. Now, we see a lot of technological revolutions, and I'm going to just spend a couple minutes for those of you that are interested in this, letting you know that there are some really great developments, and there is hope. There is hope. So soon lithium metal will kill lithium-ion batteries. If you're driving an electric car, unless you have an extension cord attached to the car, you need a battery to drive it. And if you want to be electrical, we want you to know there's new technology that will replace lithium-ion batteries. We can now take the lithium metal to make those batteries out of oil field brines and out of in aqueous solution, and we can go directly from brine to metal. This has come out of MIT. There's a company called Pure Lithium. It's a private company in Boston that has figured out how to make a battery from American brines left over from the oil industry very quickly, very cheaply. And one of these batteries put in your iPhone probably lasts a week without a charge. So technology is moving very rapidly to improve the quality of the battery. There's a lot of copper in those batteries. There are layers of copper metal and lithium metal and copper metal and lithium metal on one side of the battery. So battery technology will get better. Now, I want to talk to you that this new lithium chemistry is an unbelievably good chemistry. So you can find this company, purelithium. And you'll find it on the internet. It's a Boston-based private company. There's about 70 people there that came out of Massachusetts Institute of Technology. We can make a very efficient battery, and I just want to tell you this battery has no nickel in it, it has no cobalt in it, it has no graphite in it, it has no rare earths in it, and lithium is very common in the crust of the earth. So it is possible for us, to some degree, to use our ingenuity and try to get there from here for our kids. So batteries, pure lithium technology, American technology. Now I want to talk to you about what I'm doing. I'm the CEO of iPulse. We're a 20-year-old American unicorn, and our people worked at Sandia National Labs. That's the most powerful machine ever built by human beings. That's the Z-pinch reactor. It's in New Mexico, and it radiates 88 trillion watts. 88 trillion watts is roughly 10 times the amount of power that all the world's power plants generate. 88 trillion watts of power. That's an incredibly powerful machine. It does that with $2 worth of electrical energy. And in order to get into this discussion, we'd have to teach you the difference between energy and power. They're two entirely different things. This is a technology that uses tiny, tiny little bits of energy to generate enormous amounts of power. And I'm going to try to give you a little introductory slide so I don't have to talk, but I'm CEO of iPulse. We're an American unicorn, and we are bringing you a fundamentally new way to use electrical energy. And we are the only company that is currently authorized to do this because all of these technologies have been developed by Western and non-Western governments exclusively for the purpose of killing you. All of these technologies have come from the dark side. When Ronald Reagan was talking about Star Wars, when you're talking about X-ray lasers, or you're talking electromagnetic pulse weaponry, all of that core technology is the same technology that we want to bring to green the world economy and make the world better for your kids and your grandkids. So let's have a look. We'll play a little film about it.
iPulse has developed game-changing technology, and game-changing means hugely disruptive to a whole range of industries. The manufacturing sector, the energy sector, the mining sector. Those will be three primary focuses for our tech.
We're talking here about pulse electrical power, a greener, more efficient, more powerful way to use electrical energy. If you're one of the lucky ones we invite to our labs, it's better than going to Disneyland.
Pulse power is not a new idea. The applications are new. So you discharge energy quickly in somewhere between 50 billionths of a second to 50 millionths of a second, and you get peak powers from megawatts to terawatts. That's pulsed power. We can crack, fracture, drill, and mine with that energy.
So you can directly experience the difference between power and energy. We just take that energy from your iPhone battery and we liberate that amount of energy for a few millionths of a second into a metric ton of water, 2,200 pounds of water in a steel tank that weighs about 700 pounds, which creates a vacuum as the bubble collapses, and it lifts that whole tank, doing a shocking amount of work. We just want people to feel how much power is liberated from that tiny amount of electrical energy.
So simply put, IROX breaks rock. What you're seeing behind me is ore from the Escondida mine in Chile. And as that falls through the column, we use our proprietary pulse power technology to burst the rock from the inside. Conventionally, we break rock by crushing it from the outside. When you burst it from the inside using a tensile force, you can use up to 80% less energy than conventional grinding technologies. And so we're able to take these large pieces of rock down to a very fine powder, but we do so very efficiently.
You have a chain of events. The primary crusher, the SAG mill, the ball mill. What we want to do is take away that SAG mill and that ball mill, bye-bye. It's a huge savings in electricity and a much lower carbon footprint.
By breaking rock along mineralogical boundaries, we're able to unlock more of the valuable metals that are trapped inside. We're seeing this translate into up to 5% higher metal recoveries, which is incredibly valuable, both in terms of the companies that are involved, as well as the new metals that are needed for the energy transition.
iPulse, iROX, iMine. These are all examples of breakthrough technologies. They have the potential to radically transform the way that we go about the act of mining and processing. It's going to reduce CO2 emissions, and it's going to make the cost of mining lower, which means that we'll be able to mine these lower grade ores more economically and with less environmental impact than would otherwise be the case.
I think this is going to be a tremendous impact and change in the mining industry. Safety benefits, the decarb benefits, obviously the increased production and the bottom line benefits. It's a quadruple win on all dimensions.
It is technology that I think will be an important part of the change in our industry in terms of how we break through with some techniques that we've used for 100, 150 years.
For whatever reasons, we have some difficulties as an industry to innovate. And here I think we have a good example that innovation is possible.
This is almost like the holy grail that the mining industry has been searching for decades. The technologies that iPulse brings will help mining industry become part of the solution rather than being part of the problem.
So, we only have a few more minutes. We have 16 more minutes. About 4 to 5% of all the global warming gas on this planet is generated by the simple act of crushing and grinding rock. So when you're holding that iPhone in your hand, when Steve built the first iPhone, there were about 15 elements in that iPhone 1. If you've got an iPhone 14 or 15, there's over 80 elements in the periodic table in your hand, all of which have to be mined. If China were to cut off the critical raw materials they're threatening to do, right now we're going back to an Apple II phone. We're going to go from number 16 back to an iPhone 2, these critical raw materials. And that applies throughout the entire economy. So we just want to tell you we have a better way to mine. We're going to commercialize it. BHP and Rio Tinto are the largest miners, and my own mining company, Ivanhoe Mines, is involved. But let's show you some other things we're doing with this technology. We are revolutionizing manufacturing, and we built a factory right here in Detroit. That's why I've agreed to come to this presentation in Detroit. We're just down the street. But we have a new way to work metal that is industrially magic, and we can make anything out of metal with a dramatic reduction in energy. We can make a Rolex watch, we can make a car, we can make luxury goods, and we're going to show you how we're doing that with this new way to use electrical energy. It's quite self-explanatory, and our local company here in Detroit is called BMAX.
Pulse power is really taking a very small amount of energy and converting it into a huge amount of power. BMAX uses pulse power to move metal at extremely high speeds. And when you're moving metals at extremely high speeds, you induce some behaviors that are very unique. There's just almost a limitless amount of applications for this technology in almost any industry you can think of. BMAX is focused on two major areas. The first is crimping of high voltage cables, primarily for electric vehicles, here in our new facility in Detroit. The second is the cold welding of HVAC assemblies, heating, ventilation, and air conditioning, primarily for the automotive market. BMAX decided to put our North American headquarters in the Detroit area because it's the heart of the automotive industry. The access to our customers is great. We also have a good pool of talent to draw from for our employees, and the technology that's available in this area is really second to none.
BMAX, using our high pulse power, has really revolutionized the way high voltage cables are being crimped. Using a magnetic field to have Lorentz forces crush the terminal into the high voltage cable, it has a lower initial crimp resistance than a mechanical crimping, making it more efficient right out of the box. And over the lifetime of the product, after it sees thousands of thermal cycles, our crimp does not relax. The efficiency of the entire system stays consistent to the end of the life of the vehicle.
Just talking about the heavy-duty truck market in North America, that market alone is potentially a $2 billion market. If it goes on passenger cars, it's probably in the $50 billion range. There's not a lot of companies out there that do what we do. Even if they started today, they're probably 6-8 years out before they even figure out how to do all of this.
All the major OEMs that build heavy-duty trucks have all accepted this magnetic pulse crimping as the process of choice for their electric vehicles going forward. Nobody in the world, I'll stress this, no company in the world has the capacity that BMAX has to produce magnetic pulse crimped high voltage cables.
First, we're going to talk about welding. So how we can weld this inner material together, which is normally non-weldable. So we put the two parts inside the coil, and we're going to push the aluminum onto the copper. The two materials are sharing electrons together. It's an atomic bonding. It's a real game changer in the industry because you can really bring the mix of different materials that are very exotic and that can be done with conventional techniques.
We've now moved into the virtual reality room at BMAX. What you're seeing on the screen now is what you just saw in the lab. The aluminum at this point is traveling at about the speed of a bullet. So we use the simulation to slow it down and optimize the entire process. The aluminum piece looks like a liquid almost, maybe like a piece of Jell-O. This material, even though it does stay solid, for a very brief amount of time, it acts like a liquid. One application of our cold welding process that we're spending a lot of time on today is heating, ventilation, and air conditioning. The contents inside of these devices, they're fragile materials. They're plastics, they're paper. So if you use a traditional process that uses heat, you can damage the internal components of the assembly and make it unusable. Our process, because it doesn't use heat and because it is very efficient at welding aluminum to aluminum, it's an ideal candidate for these parts.
So we talk about the heat. Now let's talk about how strong the welds are. We did pressure tests in order to test the integrity of the weld. So we pressurized the tube to around 200 bars, and we demonstrate that the weld are stronger than the molded material itself, as the tube failed right in the middle and nothing happened in the area of the weld on both sides of the tube.
We can form very difficult materials, and we can form them into shapes and sizes that other technologies just can't achieve. We did perfume caps for Dior perfume bottles, and the shape could not be made with any other process. And you can see as the shock wave moves down the length of the cap, and then it actually reflects and bounces back. And we use both that initial shock wave and the resultant shock wave to complete the forming of the part. And the whole operation takes about 200 millionths of a second. Even though it looks like a part that was hand engraved, we were able to make millions of these parts by using the BMAX electrohydraulic forming process.
All of BMAX's processes are very environmentally friendly. We pull very little energy off the grid. We have no gas emissions. We use no cutting fluids or any dye lubricants that could seep into the ground. BMAX has some very unique advantages in the market to our customers, to the OEMs and the Tier 1s. Frankly, it's beyond what most engineers can believe.
So, we're just talking about that because we're here in Detroit, but if you can just imagine making a Porsche in, say, 200 millionths of a second, your eye can't see 200 millionths of a second. So there's an old expression that there's no truly disruptive technology that is distinguishable from magic. If I had a cigarette lighter and went to a caveman, he would think it was magic. But right here in Detroit, we can make anything out of metal in a couple hundred millionths of a second. It uses very little energy. We can make a watch. We can make your glasses. We can make a car door. And we have over 600 industrial customers. So that's the manufacturing part of this. Now, with 8 more minutes, I want to tell you what my dream is. I was born in 1950. I'm scheduled to be 75 years of age in August. And so we're in a big hurry. We're going to bring the world an unlimited amount of global warming-free, cheap electrical energy for 8 billion people on this planet with no global warming effects. We're going to completely solve the problem. And I've rarely spoken about this publicly, but we're really and truly 100% going to do it. We made you a short film to tell you how we're going to do it, but we actually have the answer to the whole mess. So here it is. This is called G-Pulse, which is the geothermal division of iPulse.
Mother Earth has given us a bounty called geothermal energy, but to tap it, we have to drill deep. If you go down 2 miles, 3 kilometers, you have a reservoir of heat there that's equal to half of all the power that we consume on the planet. Half of it. If you're successful in going down to 3 miles, 5 kilometers, you can tap 5 times the energy that the planet consumes every day. 5 times. So there's no energy crisis. There's a crisis in our ability to get the abundant energy that's right under our feet.
We don't need to build nuclear power plants. We don't need to pave the earth in solar cells. We don't need to chop up birds offshore in windmills. We can just utilize the heat of the earth. But we can't do that without a better way to drill and tunnel. And that's what G-Pulse is doing.
The G-Pulse drilling process, which utilizes pulse power and a conventional drill bit, fractures the rock and removes it in very small pieces. It's a technology that will allow us to drill into granite very, very quickly and at a fraction of the cost of today's drilling technology. Conventional drills, even diamond bits, wear out quickly in granite. You can take pulse power, fracture the rock so that the drill bit can grind out the rock quickly without wearing out the bit. That's G-Pulse.
So at the interface of our tool and the rock, with very powerful electromagnetic pulses, the rock stops thinking it's a rock. It thinks it's a gas. It just falls apart.
So you just keep on sending that drill bit down, a bit like Pac-Man. Chomp, 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 all the way through. So much quicker than conventional, so much quicker. That means that we've got this continuous loop. We can take water down, we can heat it up in the rock right at the very bottom, and we bring the steam up out on the other side.
And if we can go in and drill these geothermal wells at a fraction of the cost, then we can quickly stand up geothermal plants and supply the energy needs of the future.
We can then tap these huge tract of geothermal energy under the ground up to 3-4 kilometers below, which is energy that can fundamentally alter the world, and we can do it economically.
G-Pulse has already reduced the cost of drilling by 70%, and we are going to commercialize it by 2027.
We're talking about a way to give human beings cheap electrical energy that's green. The scale of that is anything beyond your wildest imagination. We're talking about liberating the equivalent of thousands of nuclear power plants.
That's where the growth opportunity really comes into play. If we can figure out how to extract geothermal energy in a commercial way, it's an infinite source of energy.
In addition to that, G-Pulse can be a tool set to mine hard rocks on a continuous basis. We're going to change underground mining from a drill, evacuate, blast, come back, muck out, into a continuous drill, 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 drill.
There's potential here that through the use of iPulse, you'll be able to conduct those same activities through a more continuous mining process, where you can develop continuous miners using iPulse technology to replace existing methods.
iPulse sits 2 blocks off the gate of Sandia National Labs in Albuquerque, New Mexico. Here you have the leader in pulse power with the largest number of experts in the world. It is probably the premier spot for pulse power today. We will conduct the research, we'll build the prototypes, and we'll integrate them into machines that can actually drill mines faster and at much lower cost than today's technology.
Okay, well, we have 3 more minutes. I just want to tell you that, when you get older, a lot of my friends have already died. You get very interested in longevity and health. But the world is in a very dangerous and desperate position right now. We've always fought wars over crude oil. I frequently said I doubted that we would bomb Saddam Hussein. It was shock and awe if there's absolutely no crude oil in Iraq. In the future, we're going to stop fighting wars over crude oil, but energy is critically important, and we need a better way to mine the materials we need to utilize that energy. Even when you have the energy, it's delivered to you by copper. It's still got to get to you in that final mile. For your microwave oven or your toaster or your electric toothbrush, your washing machine, your dryer, and all of you have touched anything in the modern world. Everything you touch, just think about it as you go through your day. When you touch something, we mined it. And if we didn't mine it, we grew it agriculturally. And if we grew it agriculturally, we needed the combines and the tractors. And we had to drill water wells to get you that food. And that food was delivered to you in trucks and trains and airplanes when you buy your blueberries from Chile in the off-season. So the energy intensity that Americans consume is crazy compared to the rest of the planet. So if we're going to help 8 billion people to get there from here, we need a better way to mine, and we need a better way to produce electrical energy. And with that, rather than engaging in the enterprise of just war, you're going to need us to help you. So I hope that was of interest. I'm Robert at ivanhoe.net, and I'm at Robert_Ivanhoe on Twitter. Yeah. Well, we only have a minute and a half. I'll take one question. Shout it out, bro. Yeah, well, we're deeply involved in water. We think water will be the world's biggest business, and we see water geophysically without drilling. So our technology enables us to look in the earth and see metals and water non-invasively, like a CAT scan or MRI. So that we do that extensively. You can see all this at the iPulse website, www.ipulse-group.com, or you can just find me on the internet, robert@ivanhoe.net. I gotta go. They won't let me go. I hope you found this understandable. To be continued. I gotta vanish. Peace. Thank you.